Hi everyone. Today we are going to talk about changing the m, or the slope, on y equals mx plus b and applied situations. So as we're looking at the very first example, it says paint and more charges $25 per square foot that is painted, and we want to draw this relationship on the graph to the right. And so we need to first decide what our x-axis is going to be. It's talking about square feet. So we're going to put square feet here. And then we'll number this 1, 2, 3, go by ones. And then our y-axis, we're talking about $25 per square foot. So this is going to be the cost over here. And it's going by 25s, $25 per square foot. So I'm going to go by 25s on this also. I'm going to skip a line so that it's not so squished with our numbering, knowing that each one of these lines represents 25. And so it says to draw this relationship, so if we have 0 square feet, then it's going to be $0. If we have 1 square foot, then it would be $25. 2 would be $50. 3 would be $75. 4 would be $100. So then I can draw my graph of this. And so from here it says, what is the number for the slope? Well, remember that the slope is the one that says per square foot per, so 25 would be the number. What does it mean in our situation? Well, we have $25 per square foot. It also asks for the number for the y-intercept. Remember, here's your y-axis, and so your y-axis number is 0. And what does this mean for our situation? What does it mean when you have a y-intercept? That is where you start. So we are starting the cost with $0. Starting with $0. And so the next part talks about a new thing. That was kind of all just review. It says a blank blank between two quantities is one in which the two quantities vary directly with one another. So this is called This is called a proportional relationship.
Students, if you would please go ahead and head to those areas designated for waiting. We appreciate your cooperation, guys. Finish up in Java City and go to those areas designated to wait. We appreciate you. Thank you. Have a great afternoon.
Thank you, Dr. Hemley. And so it says if one item is doubled, the other is also doubled. Because of this, it is also called a direct variation. So there's two new vocabulary words for you today: proportional relationship and direct variation. That means that we are varying directly with one another. If one item is doubled, then the other is also doubled. This proportional relationship can be seen on a graph where the slope of a straight line is positive, and where the line goes through the origin. Remember, that's the 0, 0. The slope then would represent the constant of variation. And we can call that the letter K. So the equation of the line could be written y equals kx, but we know it more like y equals mx. So notice the m and the k are in the same place. The m is your slope, and that is the same thing as the k, which is the constant of variation. And so letter E says, is this relationship proportional? We're talking still about the square foot thing. And so, example. And so, let's go back to the relationship that it's talking about, the proportional relationship. If the slope of a straight line is positive, is this a positive line? Yes, it is. If the line goes through the origin, does it go through the origin? Yes, it does. So then, yes, this is a proportional relationship. It is a direct variation. It says, give evidence to support your answer. Well, we just said it. The slope is positive, and the line goes through the origin. So when the slope is positive and the line goes through the origin, it is a proportional relationship. And so this one does that. All right, so the next part says draw a new graph on the grid above to represent a change in the slope to 50. So let's go ahead and draw a new graph. We're still starting at the 0, but this time the slope is changed to 50. Well, that tells us to go up 50 and right 1. Up 50, right 1. Up 50, right 1. And let's draw our new line. This is for the letter F. Here's the letter F. And so G says, what has happened to the graph now that the slope is changed to 50? Well, here was our original line, and here is our new line. It has gotten what? What did the line do? It went from here to here. What did the line do? It got steeper. The line got steeper. So the M has changed and the line got steeper. That's going to be a new vocabulary word. The line got steeper. What does that change mean for Paint and More? Well, it was $25 per hour. Now it's $50 per hour. So what does that mean? They get more per hour. They get more per hour. Now it's asking us to draw another line, but this time we are going to do a change in the slope of 10. And I'm going to do this in a different color also. That means that for 1 hour, it's going up 10, which is a little bit below, just right above the 0 on this, since we're going by 25s. Then, since this is 25, it's going to be right below that one for the 2. Then 3 would be 30, so we're going to go right above that 25 mark for the 30. 4 would be 40, so right below the 50. And then 5 would be 50. So if I can just get to that 50 and I know it's starting at 0, then I can connect those points pretty easily. All right, so there's my new graph, and that's the letter I. That's going up by 10. And it says, what has happened to that graph now that the slope is changed to 10? Well, if you look at it, this one was getting higher faster. This one is getting higher slower than that original line. Remember, this is our original line. This line is flatter than the original line. So the line got flatter. That's another new vocabulary word, flatter. The line got flatter. And what does that change mean for Paint and More? Well, remember, it was $25 per hour. Now it's $10 per hour. So they get less per hour. But notice how the graph, it's all about what how the graph has changed. The graph is flatter on this one. So now let's see what that looks like when we are faced with just a regular graph. We want to see what that looks like with just a regular graph. And so on the back side, you'll notice just with normal y equals mx plus b, not with real world applications, although it's easier to start with that because you can see how it works a little bit easier. So here we've got just the parent linear function. Does anybody remember what the parent linear function is? It's y equals x. Good job. And so what is the m for that equation? Remember, the m is the one next to the x. It's an understood 1. Very good. And the b is going to be 0. So if we were to fill in the table for this, every y would be the same thing as whatever x is. So -2, the y would be -2. For x is -1, the y is -1. 0, 1, and 2. For every x, it's the same as every y. So then when you graph this, and I apologize for the graph not being very good on this one, but when we graph this, -2, -2 would be about here, -1, -1, 0, 0, 1, 1, and 2, 2. And then when we graph that, or excuse me, when we draw the line, it is a positive slope but going through the origin. And so it says when you change the slope m, it changes the slant of the line. So remember, the slope of the line is the slant of it. And so when we change it, it will either get steeper or it will get flatter. We will also see another change here in just a second. When we look at this next one, it says, how has the parent linear graph changed if the slope is changed to 1/2? Well, let's look at what it was. It was m equals, what is the slope for the parent linear graph? Remember, it's y equals x, so the slope is a 1. So it was a slope of a 1. Now the slope is 1/2. What do you think is going to happen if the number gets smaller? Let's look back here. For this one, it was 25, and it's now changed to 50. That means it went up, and so it got steeper. So when the number got bigger, the line got steeper. But when we look at the one where it was changed to 10, it was 25. Right here, it was 25, now it's 10, so the line got, or the number got smaller, the graph got flatter. So let's go back here. Did the number get bigger or smaller? The m got smaller, so it is a flatter line. And we can look at that in our calculator too. If we were to type in just y equals x, that's our parent linear function, and then let's just type in on the next one, let's type in 1/2 x. The first one that it draws is the parent linear function. The second one that it draws is the y equals 1/2 x, and notice how the second one got flatter than the first one. So we can see that it got flatter based on the calculator picture as well. All right, the next one says, how has the graph changed if the slope of y equals 2x minus 1 is changed to 7? Well, if we say the slope was a what? A 2. So the slope was a 2. Now the slope is a 7. What has m gotten? It's gotten bigger, that's right. And so when the m gets bigger, the line gets steeper, right? So because it's talking about how has the graph changed. So this one has gotten steeper because the number got bigger. Let's look and see if that's the same on the calculator. So again, let's put in y equals 2x minus 1. And now we're changing the slope to 7x minus 1. So let's see the graph. Here's the first graph. And then here's the second graph. Ooh, notice how it went up faster. So this second line got steeper than the first line was. Now let's look at the last one. It says describe the changes from y equals 1/3 x plus 1 to y equals negative 2x plus 1. What's different about those two equations? That's right, the slope is different. So we've got a slope of 1/3 here, and it's now a negative 2. So it was m of 1/3, but now the m is negative 2. So first of all, not thinking about the negative making it a smaller number because the negative is just extra in this case. What happens when it goes from 1/3 to 2? Does it get bigger or smaller? Not negative 2, just the 2. 1/3 to 2, it's getting bigger. So that means it's going to be steeper. Now that negative, when we talk about graphs, that negative on the slope changes the direction. So that negative, since it's a negative, that's going to change the directions. Let's see what happens here. If we put in y equals 1/3 x plus 1, and then we do negative 2x plus 1, let's watch what happens. The first one is going to be the 1/3. Here's 1/3. And here's -2. Notice how that -2 flipped directions. It's a negative. You can also see that it's steeper. Okay? If we were to take off the negative, let's see what happens. Take off the negative. There's 1/3. And there's 2. Notice how the 2 got much steeper than the 1/3. The only thing that the negative did to it, so I'm going to go back here and I'm going to put the negative back on it. Put a negative. Nope, that's not what I want. So we're going to do a negative. One moment. We want to insert a negative. Okay, so if we put the negative back on there, the 1/3 and the -2x, the negative changes the directions. Okay, so it's called reflection. It's a reflection. So the negative made it be reflected. So let's do a recap here. When the M changes, the new graph can be steeper because the M is bigger, or flatter because the M is smaller. But it can also be reflected. So it could be steeper and reflected, or it could be flatter and reflected, because the reflected comes from the M being negative. Have a wonderful day.